whether it's ERVs, whether it's nuclear DNA sequences, mitochondrial DNA sequences. But my whole point was that these phylogenetic classification methodologies, it's based on an assumption that common ancestry is true. But
can we demonstrate
we do see this accumulation of but the thing is, if we see a significant loss of information, loss of function, and genetic entropy, which I don't believe has been debunked yet,
it is
that
not
initial assumption is all it is an assumption.
So first of all, as you said, we can demonstrate common ancestry. You believe it up to an extent, like the kinds, the archetypes, or whatever, for instance. But genetic entropy isn't taken seriously by geneticists because it has failed.
Well, the thing is, I have many quotes from. I mean,
I can show you the data. I can show you I honestly, if someone says a quote about it, if I give you a quote, 100 quotes about people saying evolution is correct, you're not going to become an evolutionist.
Well,
likewise, if you send me 100
but you're trying to say that population geneticists don't take it
they don't.
I mean, if you look at Alexei Kondrashov, he was the professor of evolutionary genetics at the University of Michigan. He said, why are we not extinct 100 times over because of these near neutral accumulation of deleterious mutations?
Wait, who said that?
I think his name was Alexei Kondrashov. I don't know how to exactly say his last name. You've got Michael Lynch, who's a professor, population genetics. His quote was, "Our results provide no evidence for the existence of a threshold population size beyond which a population is completely invulnerable to a mutational meltdown, mutation accumulation, the extinction of small populations." The thing is, they have to hold to their worldview, their primary axiom.
No, they don't.
It's a secret among population geneticists that this is a major and detrimental problem.
It's not, though.
I'm giving you quotes.
It's actually not, because, and here's why. Again, quotes really don't do anything, because we can show
quotes from population geneticists, evolutionary.
Have you actually read the technical paper on it?
I sat and read that letters to a creationist, and none of those arguments were very important. I want to hear your best argument against these accumulation of near neutral mutations that's degenerating our information system.
Actually, geneticists have already debunked it, because for one thing, creationists ignore beneficial mutations, which offset.
I've already told you that these beneficial mutations are rare, so natural selection may amplify the beneficial mutations and get rid of the, most, because obviously natural selection is acting on the phenotype. It's not going to recognize one single point mutation on a nucleotide. It's got to act on the phenotype as a whole. So at the end of the day, those near neutral mutations are not selected against. It doesn't matter about beneficial mutations. It's a straw man argument. It proves that Scott guy in that letter to creationists, he didn't even read anything that John Sanford provided. Because
I'm sorry, you have to say that again. You're saying a whole lot about you were saying a whole lot at one time. For instance, let's break this concept down.
Well, let's talk about beneficial mutations. You're saying that beneficial mutations are going to counteract these accumulation of near neutral mutations, but
which has been shown. Even the model that that Sanford was basing his model on was oh crap, what was his name? Kimura. Kimura's model. He was ignoring that Kimura had pointed out that beneficial mutations would offset the harmful and near neutral ones.
The near neutral mutations are not selected for or against, because you're going to have to show me thousands of these examples of adaptation via beneficial point mutation.
Why?
Well, of course, because you even admitted that the overwhelming amount of mutations are near neutral. If you're saying that beneficial mutations are going to help with this, where are the beneficial mutations in man? Because, Jackson, it is very well documented that there are thousands of very deleterious Mendelian mutations accumulating in the human gene pool, even though there's strong selection against such mutations. So where's all the beneficial mutations in man?
I've provided you but one already, which is the apolipoprotein A1, which is beneficial. It's beneficial in the sense that it provides a selective advantage.
Loss of specificity, though.
What is Okay, so when you said specificity, what we're talking about, is this a thing that's now better at its job than it used to be? I don't know what you mean when you say it's lost specificity. It's now better.
Because well, I'll explain it to you.
It's better at metabolizing cholesterol than it used to be.
No, because
that's what this thing already did. This protein already did that job.
Well, do you want me to explain what I mean by loss of specificity? I'm saying that the fact that the person with the mutation is unable to produce the normal levels of HDLs, they're known, and you probably know this too, they're known to perform a valuable role in moving bad cholesterol. This suggests that there could be a health downside to this mutation. It's exactly like sickle cell anemia. It's exactly like the
It's
HIV
not.
example. It
No.
is. Yes,
Apolipoprotein A1 is not like that at all. It's not an example of heterozygotic advantage. I have not seen any technical literature to indicate that that is the case.
Well, the thing is, you can give me one or two. Obviously, we're going to agree to disagree on that one. You know, I just showed you why it's a loss of specificity, but where are these thousands of examples of, because we document thousands of deleterious Mendelian mutations, but we struggle for 2 hours to even agree on one solid beneficial mutation.
So here's what I defined what a beneficial mutation is. It provides a selective advantage. And in this case, and it doesn't matter whether the gene, it doesn't matter what has happened to the gene per se. It is providing this, it underwent a mutation that now provides a selective advantage.
That's still deleterious in another. If it's polyfunctional and polyconstrained, even the smallest change is deleterious.
What does that mean? What does polyfunctional and polyconstrained mean?
Poly meaning many, functional meaning, you know, performing many functionals in even a single nucleotide.
So how is the apolipoprotein A1 polyfunctional?
I'm saying that our genome. I'm saying that our genome is polyfunctional.
So the whole genome is doing multiple functions?
Our genome is performing multiple functions. One gene is regulating another gene. I mean, there's overlapping codes. It's the double helix. They're all interacting with each other.
Whoa, what? That's not what Okay. The regulatory genes are doing specific jobs. You have one job. I mean, they might not necessarily have one job, but they
have multiple jobs, polyfunctional.
The point of their job is, at least one of them, is to regulate other genes. Okay, that's their job. I don't understand what you're trying to get at, because
I'm trying to say if the majority of our gene sequences are proven and shown to be functional, any change in our genome is going to be deleterious. That's what I'm trying to say.
Okay, and here's why I explain that it's not. Because you have examples.
I know you think you've explained that, you know, they don't perform roles, but I think it's pretty evident that they do perform roles, because
because you haven't provided examples that they have. You've pointed me to these ERVs over and over, which we've already agreed. The few that actually have any job have jobs. I'm totally willing to concede that point, but the majority of them don't have any jobs.
Well, do the majority of okay, but
ERVs don't have any jobs.
The deleterious mutations, are they going to display any clear phenotype? Like, let's say it's just a neutral mutation. Is it going to display any clear phenotype?
Not necessarily, no.
Okay, so natural selection acts on the phenotype as a whole. It doesn't act, you know, on a genomic level
it does.
Per se. Well, it's looking. We're all mutant. You know, one maybe more mutant than the other, but natural selection does act on the phenotype.
It acts on the phenotype and the genotype, yes, or genome.
Okay, so how come there's no beneficial, you know, birth anomalies being seen? You know, how can we see so many birth defects, but we're not seeing any, you know, positive outward phenotypic beneficial mutations that are as evident as these birth defects?
So, for instance, when I was referring to Ragavalia, which have duplicated these genes, they now have novel propeller fans, which allowed them to invade a new environment. Is that or is that not beneficial to them? Is that not selectively beneficial?
I'm not crazy familiar with that. So even if I concede that, say, because to be honest with you, every example that I've seen an evolutionist provide, it has, through further research and looking into literature, provided sufficiently some type of deleterious effect. Do you believe that that type of example is sufficient to, say, prove pond scum to people evolution? I mean, is that type?
No, that wasn't my point at all to do that. I was merely pointing out the existence of beneficial mutations. I'm not even talking about evolutionary history. I'm merely explaining how the process of evolution itself works.
Okay, if I concede that that's, you know, a beneficial.
Well, I can move on.
There's no deleterious
to another one then.
Okay, I'll just let's just say it is. The thing is, I think I might have said this before. You need to understand that obviously a population it's going to be undergoing genetic decline due to the vast numbers of slightly deleterious mutations that I'm talking about, because selection
We
can
don't see that,
amplify this
actually.
beneficial mutation. Well, you're saying selection's amplifying this beneficial mutation, right? It's amplifying it now. And it's
In what?
in the one you just talked about with the.
Well,
Was
no,
it
it's not
elephant?
amplifying that. It's created this novel structure from these genes. The same with the notothenioid fish, was that you had a gene that had a totally different function that was duplicated. It developed a new protein and a new function.
But is that going to stop the degeneration process
There's
ultimately?
no degeneration process that's been observed. That's not
Okay,
being
so-
observed in actual real world populations.
Okay, so you don't believe that these near neutral mutations are degenerating our genome, right?
I didn't say I didn't. I didn't say I didn't agree with that. They probably are. But what I'm saying is that the genetic entropy that you're
I'm
talking
just saying
about,
there's nothing that can stop it, much like nothing could stop a rust on a car. Sorry, I had to use an analogy there.
no, that's no. That, I mean, that's fine. It's. I'm not saying that near neutral mutations aren't occurring and accruing in the genome. That's not what I'm saying at all.
Okay.
What I'm saying is that the magnitude of which these occurring is not causing genetic entropy, as Sanford would like us to believe, and as other creationists would like us to believe. That's not happening. It's not being observed in populations.
So you don't think that there's any, like, for example, RNA viruses, it's if you look into the Spanish flu, H1N1, they killed between 50 and 100 million people. By 2009, it was extinct after 15% of its genome of 12,600 nucleotides had mutated. So it actually, and if you look at the graphs in Genetic Entropy, the book, it followed a perfect linear mutation accumulation rate and a perfect exponential biological decay curve. So that means the H2N2 and H3N2 outbreaks are now following the same decay curve. So
why don't we see that in anything else?
now. We're seeing it in real time.
Why don't we see that in anything else? I'm not familiar with those examples, and I'm very leery of anything Sanford says because he's.
I'll send him to you.
But is anyone else aware of those examples?
Well, like I said, I've given you quotes from.
But have you yourself read the technical papers on the examples he provided?
Okay, well, look up James Crow. He's another. I've already given you 3 quotes from population geneticists.
I don't care about the quotes.
I just want to give one for the audience. I want them to hear this one. So he said, I do regard mutation accumulation as a problem. It is something like the population bomb, but it has a much longer fuse. So these evolutionary population geneticists, they are recognizing it as a problem, but they can't concede it the way we do because they have to hold to their primary axiom. They have to hold to molecules.
In fact, I would say the exact opposite, because what I see in researchers is that they are honestly struggling with the actual data that we see. And I can turn that around and say, look at Todd Wood. He said evolution is definitely true, but that he rejects it because he wants to believe in the Bible. Well, and he's not the only one. Kurt Wise has said the same thing. And I could go on. We could look at other examples. So I don't care about quotes. I really don't. They don't mean anything.
Well, because